Something interesting I'd like to talk about today is whether there could be life in our solar system. Specifically, could it be located on Jupiter's moon, Europa? So this all started after some scientists located a ocean on Europa. And they did this because they noticed an irregularity of Europa's magnetic field. Its poles are not stationed at the geographic north and south poles. So to illustrate that a little bit better, imagine if our magnetic poles were located on Texas and located at Texas and India. And they were moving around from like Texas, India to like Florida and China or something like that. They're just moving around. And so this was peculiar, and they looked into it and they found out that it was caused by Jupiter's rotation. So Jupiter has a magnetic field rotating and moving around, and Europa has to have some kind of conducting element that generates this magnetic field in an irregular pattern. And scientists think about it, and they don't think it could be the core. And they believe it to be a salty ocean located under the icy crust of Europa. So Europa is an icy moon. It's all ice on the surface. But this discovery leads them to believe that there's a saltwater ocean underneath. So fast forward a bit, and more's learned about this ocean, and we kind of discovered that this ocean is more similar to Earth than you would initially think. According to the University of Texas at Austin, the Europa's oceans have pressure and temperature conditions that match up with some of our oceanic regions like the coast of Greenland or the Antarctic Ocean. This is important because life as we know it needs water to exist, and it needs water in a somewhat stable configuration to exist. According to London South Bank University, water is important for life because you need it as a medium for chemicals to react and make complex organic molecules. Other mediums such as N2, H2S, or NH3 provide an environment with reaction rates that are not suitable. They can either be too slow at lower temperatures, or some of these mediums don't get hot enough as a liquid. They can't sustain a hot enough liquid to have adequate reaction rates to form organic molecules, or they can exist as a liquid, but their reaction at high enough temperatures, but the reaction rates are too fast and violent, so they're not actually able to form life adequately. And with prospects like this, NASA has started looking into going to Europa, and they actually already sent a spacecraft called Clipper to better understand the moon's icy surface and what lies beneath it. The craft was fitted with some of the best equipment to survey the moon. It has cameras, spectrometers, so to see the surface and understand its composition. It will have thermal instruments to pinpoint where eruptions on the surface could be. It will have special devices to capture particles in the atmosphere and in orbit and analyze what those particles contain. And you may kind of be asking yourself, okay, this is all grand and cool, but what does this really mean? Well, how would the public react? Well, according to astronomy.com, it's kind of unclear. It's hard to tell what this could mean. People could rejoice, it could elicit a messy reaction, or they could not be too bothered. It all really kind of depends. They're like, if you kind of think about it, there are some interesting questions with Fermi's paradox. And if life could, like, there's some interesting questions to be asked, because if life could pop up twice in the same solar system, yet when we look out into the rest of the solar system, there's no life, that could sprout some interesting questions. Like, what is special about this solar system? Is it chance? Why does our solar system seem to be the only one with life? I mean, that's a question you could pose now, but if it happened twice on two separate occasions, you could ask, why twice? Or maybe you could ask the question, okay, maybe life pops up more in the universe than we give it credit for. Why are we so bad at detecting it? Maybe there's more life out there than we know, and we just kind of stink at detecting it for one reason or another. These are all interesting questions and interesting thoughts to consider.